In the first part of this video series on calculating manure production, we went over how to calculate the raw manure produced by animals and the amount of uncollected manure that will be spread on pastures. In the second part of the video, we talked about the additions to the manure storage from wash water and bedding. The final step, which we'll cover now, is how to calculate rainwater additions. Rainwater can be added to manure structures in two ways: what falls directly onto the surface of an outdoor storage structure and what gets directed into the storage from runoff of nearby surfaces, such as barn roofs, exercise lots, walkways, etc. There are several factors that need to be considered for each of these rainwater sources that we'll go over here. First, the amount of rainfall that occurs will vary based on what county you are in and the month of the year. We're making this calculation for planning purposes, so we can use average rainfall data by county and month, which is compiled in Supplement 7 of the Nutrient Management Technical Manual. Once we've drilled down into the county and month, there are additional factors to consider. For rain that falls directly onto a storage, we need to consider whether some of that rainfall will evaporate back out of the manure storage or not. To determine whether evaporation will occur, we need to consider whether the manure storage will develop a crust on top of it. A crust is a dried out mat of fibers that floats on top of the manure storage. It allows rainwater to infiltrate into the storage, but prevents evaporation back out of the storage. Supplement 7 of the Technical Manual lists 3 questions about the manure management system that will help you determine whether a crust will form and whether or not to account for evaporation. First, does the storage structure contain fibrous organic bedding, such as straw or a lot of waste hay? If no, then a crust won't form and evaporation will occur. If fibrous organic bedding is used, then you need to go to the second question, which is whether the manure is added to the storage from a pipe near the bottom of the storage. If manure is added from the bottom, then the surface of the manure storage will remain relatively undisturbed and a crust will form on the top, in which case no evaporation will occur from the storage. If manure is top-loaded into the structure, then you need to go to question 3, which is whether milking parlor wastewater is added at the top of the manure storage structure. If milking parlor wastewater is added at the top of the structure, the additional water from this system will disperse the manure added at the top and prevent a crust from forming, meaning evaporation will occur. If no wastewater is added at the top of the structure, then top-loaded manure with fibrous bedding will form a crust and no evaporation will occur. This series of questions can be a little bit confusing to keep track of, so here are a couple tips to help you think it through. First, think about whether the conditions exist for a crust to form on the structure. If you get a crust, then no evaporation will occur. And there's only 2 scenarios in which a crust doesn't form. First, if the farm doesn't use any fibrous bedding, then there is no material to create the crust. Second, if both manure and milking parlor wastewater is added to the top of the structure, then it will disperse the material at the surface of the storage and prevent a crust from forming. Once you've determined whether evaporation will or won't occur from the structure, you can drill down to the appropriate row of data in Supplement 7 for rainfall directly onto the structure. For rainfall that falls onto nearby surfaces and runoff is directed to the storage, it used to be necessary to determine whether those surfaces were paved or unpaved. Paved surfaces and impervious surfaces like roofs will direct almost all of the rainfall into the manure storage. Unpaved surfaces, such as dirt exercise lots, may infiltrate some of the rainfall if there is good porosity in soil structure, leading to less runoff to the manure storage. However, after evaluating the most common conditions on farms, we've determined that almost all dirt surfaces in barnyard areas behave like paved surfaces because of the compaction level. So for calculating rainfall directed to the storage, use the row for paved surfaces. Now that we've drilled down into what specific rows of the table to use in Supplement 7, which is based on the county we're in, whether evaporation will occur from the structure or not, and the surfaces being paved, we will need to consider what months the rainfall will be accumulating over for each manure group. Let's go back to the example scenario we've been working on, where our spring manure group accumulates from October through March, and our fall manure group accumulates from April through September. In this case, for calculating rainfall directly on the structure and rainfall directed to the structure, We would sum up the total rainfall over the months in each collection period to get a total number of inches of rainfall. Here, for a farm in Lancaster County, and let's say we don't need to account for evaporation because we have a crust, we would have a total of 17.79 inches falling directly on the storage for the spring manure group, and 22.54 inches falling directly on the storage for the fall manure group. For rainfall directed to the storage, from paved surfaces we would have a total of 9.74 inches in the spring manure group and 13.18 inches for the fall manure group. Now this gives us the depth of water that will accumulate on either the surface of the manure structure or on the surfaces contributing runoff to the structure. We need to convert this depth into a volume. To calculate the volume, we must multiply the depth of rainfall by the area of the surface on which the rain is falling. For a rectangle, the volume is depth of rainfall times length of the area times width of the area. For a circle, which is a common shape for rain falling directly on a manure structure, the volume is depth of rainfall times pi, or 3.14, times the radius of the structure squared. In our example scenario, let's say that a concrete exercise lot with dimensions of 50 feet by 80 feet has runoff directed to the storage. The circular manure storage that receives rainfall without evaporation has a 30-foot radius. Let's calculate the rainfall additions for the fall manure group. We previously calculated the depth of rainfall without evaporation directly on the circular manure storage during the collection period from April through September was 22.54 inches. We convert this into feet by dividing by 12 inches per foot, then multiply the rainfall depth by pi and the radius of the storage squared, or 30 feet times 30 feet. This would give us an answer in cubic feet, but we want our answer in gallons, so we have to multiply by a conversion factor of 7.48 gallons per cubic foot. The result is 39,705 gallons. We can do a similar calculation for the volume of rainwater directed to the storage from the exercise lot. We previously calculated this depth of rainfall as 13.18 inches for the fall manure group. We divide this by 12 inches per foot, multiply by the length and width of the exercise lot, and multiply by our conversion to gallons for a result of 32,862 gallons. Added together, this is a total of 72,567 gallons of rainfall. We can repeat these same calculations for the rainfall addition to the spring manure group, which accumulates from October through March. We just have to use the depth of rainfall calculated for this time period as the starting point in our calculations. The dimensions for the circular storage and the exercise lot and all the other conversion factors stay the same. We previously calculated that for the spring manure group there was 17.79 inches of rainfall directly on the storage and 9.74 inches directed to the storage from the exercise lot. Penciling out the calculations, we get 31,338 gallons of rainfall directly on the structure and 24,285 gallons of rainfall directed to the structure, for a total of 55,623 gallons of rainfall added to the spring manure group. The rainfall addition is the last number we needed to calculate our total estimated manure accumulation. Let's add the rainfall numbers for the fall and spring manure groups to the table we've been compiling. Now we can calculate the total amount of manure generated for each manure group, which is the raw manure production minus the uncollected manure plus the wash water plus the bedding plus the rainfall addition. We have 433,136 gallons of manure accumulating for the fall manure group and 408,653 gallons for the spring manure group. It's important to remember that this series of calculations is just an estimation of how much manure will be generated on a farm. This calculation process is only done when a farm doesn't have the records in place of the actual manure quantities generated. This process would be used in scenarios where a proposed farm needs to get an Act 38 nutrient management plan as part of the permitting process before it is even operational. Once a farm is operational, it should use its own records of manure production by measuring the manure quantities actually generated in each manure group.